Hey, this is Todd. You're watching Real Space Junk. Today we're going to take a look at the Explorer 18, otherwise known as the Interplanetary Monitoring Platform, or IMP. We're going to look at some of the ICs that were the first ones that flew in space. Today we're going to look at this Texas Instruments SN514 from the early 1960s. As you can see, it's sitting in its Texas Instruments container. You can also see that this is made with the black resin and very crudely made versus the later metal encapsulated versions of them. You can see that the leads are so short on this that they won't even work in what became a standard size carrier. I'm going to take the 517A out of this carrier to see if I can get the 514 to work in it. It seems like it would be the right size, whereas the other ones are much too small. In 1958, Texas Instruments engineer Jack Kilby created the first integrated circuit, revolutionizing electronics. While working alone during the summer, Kilby connected all the components, resistors, capacitors, and transistors, into a single piece of germanium. Later that year, he demonstrated it successfully, proving the entire circuit could be miniaturized. Just over 4 years later, his monolithic ICs were used to provide the telemetry for the IMP satellite. It looks to me like the pins are all lined up and touching the gold contact, so I think we're ready to test it out. Okay, I've got the yellow connected to positive voltage and the white connected to ground. And I put the probe, you can see the light there on the probe, on output, and I'm going to put the pulsar, I'll put it on input A. As you can see, when I send an input into it, pulse input, probe works. Looks like this works right. Realize it's a bit of a mess right now, but here's what we've got going on. We've got this keyboard, numbers 1 through 4 set up to inputs A, B, C, and D. As you can see, they hop on this breadboard and go into this chip. So the yellow and green on the bottom is going to positive voltage. The white and black on the top is the negative ground, and then you've got the red and red right here is the output, and you've got the yellow on top, the blue on top, and the two reds on the bottom here are inputs A, B, C, and D. And as you can tell, this is a NOR gate, so no inputs right now is a positive response. Then any input, single input, double input, any input turns the light off. So the only positive is when both or all keys are not depressed. Any depressed key turns off the light. Hey, thanks for watching Real Space Junk. If you could, take a second to like this video and subscribe to Real Space Junk.